we're all from Jess. We've been there now, 6 years?
6 years now.
6 years at Jess. So a bit of context on our school. Jess originally opened in 1976. That was a primary. And they opened the secondary up in the Arabian Ranches in 2005. So we're in our 8th year now. Achieved quite a lot. We've got about 800 students from 40 different nationalities. We're a non-selective school, so we've got like a wide range of abilities throughout all the year groups. It's a nice mix. And we're here to talk about a bit of algebra today, framing it in a meaningful context. Now, as many of you already know, algebra, the teaching of algebra typically is very sort of procedural driven, with no sort of link to the real world. How often have you heard students say, why do I need this? When am I ever going to use this? They can't see a connection with what they're learning to the real world. And that's sort of like a big problem. So I know what we try to do is teach, algebra in the context of real life applications, so students can develop a better understanding of why they're going to use it and where they're going to use it. Now, I know from my own experiences, you probably have the exact same when you were younger. I was always good at maths. It's good. But I never really had a true understanding of what was going on. I could solve any equation, that was it. Doing calculus, yeah, I can do that. But I didn't really understand what was going on. And that was someone who was good at maths. Now, I think of all the other people who say, I'm terrible at maths. How often have you heard parents even, I'm terrible at maths. Now, if they were terrible at school, they were probably completely lost at what was going on at school. So my job, each and every lesson you try to get these kids to make these links to real life context. So I'll give you an example now of a typical question, how I might start my lesson. We go through a few bits there. Okay, I'll stop you there. Of course, kids, they know all about Xboxes. I don't. Pretend I do. So straight away, I've got this up on the board, or either I'm talking about this. They've been a lucky winner on the Chris Fade Virgin Radio show. They all know Chris Fade straight away. They're all interested. We've got their attention. They've won a voucher worth 2,500 dirhams. And it's for Virgin Megastore in Mall of the Emirates. So they're, oh yeah, that's good. So you've got year 8, year 9 kids. I'm into this. Right, you're going to buy the brand new Xbox 360 Slim. That's the price. You're going to buy an extra controller. Brand new game retails at 269 dirhams. First question straight away is, how many games can you buy? Anybody can calculate in their head. How many games can they buy? They're going to buy the brand new Xbox. They're going to buy the extra controller. And they're going to buy several new games. Straight away they're getting down to it. They're calculating straight away. They've got the little mental maths books. Well, depending on the class, they'll get down either working out, or if lower ability might be using their calculators. So I leave them the task, how many games can they buy? After a few minutes they discover, anybody know the answer? Guess?
5, maybe.
5, yeah, that's what it is, right? They work it out quite quickly, well, not say quite quickly, but they can buy 5 games. Okay, so now we start, okay guys, so you've got 5 games you can buy. How did you get that?
Okay, I estimated first of all.
Okay.
I rounded 899, it's almost 1,000.
Yeah.
So 2,500, take away 1,000, it's almost 1,500.
Yeah.
So I rounded also 159 is almost
okay.
150.
Yeah.
So I added it to the 1,000.
Okay.
I put it with it. So 1,500 divided by 300, it's almost 5.
Okay. Now the kids either estimate or actually getting the exact sort of numbers. They'll find out 5 games. We discuss how they've got that exactly. So now we say, okay guys, can we construct some sort of equation? Now in your groups, I tell them, okay, in groups of 4, construct some sort of equation to represent your calculations you've just done. Now typically this is what came back, okay? So they discuss themselves, little groups, and they come up with, okay, we have 2,500 to spend. And we buy it, 899. We buy the extra controller, which was 159. And then we're going to buy a number of games. And usually they came up with this plus X. That's what typically, with my year 8 class, for example. Okay, well so we add these two together, which came out at 1058. plus x. Okay, guys, solve the equation. What do? They take 1,058 off both sides of the equation, and they've got an answer, 1,442. And they're happy with that. Now, guys, let's think about this. What's that x telling us? This unknown x. And they're like, oh, it's the amount of games we can buy. So realistically, can we buy 1,442 games at 269 dirhams a pop? No, that doesn't sound right now. So then they work out themselves their equation that they're putting together. That doesn't sound good. So again, we go back to playing around with it, and eventually through discussion, what happens next? They usually put in 5x because that was the original answer, how many games they can buy. Solve it again, and they still get an answer around 300 games. No, that's not working. And eventually you'll have, through discussion, they'll come up with the proper equation. I said, that's brilliant. You've constructed your own equation. Let's say, example, the first place was a 10,000 dirham winner. How many games can they buy? So instantly they go in, they're forming their own equations, 10,000 equals 1,058 plus 269x, and bang, they work out how many games you can buy. Oh, it's amazing, I can buy 30 so games, that's brilliant. I said, look guys, forget about the money, can we change this into a formula? What can we use for a formula? And again, through discussion, they usually come up with C for cost. They've made their own 158 plus 269x. Brilliant, they're happy. They've made their own formula now. And then, well, what about if you wanted to buy 2 controllers? Through more discussion, then you're going back to the original one back here, and they're bringing in new letters Y. And just discussion, you get 10, 15 minutes, great discussion. They're loving it. Because they can see, they don't want to know how many games they can buy. They buy into it straight away. It's particularly the younger kids. And you can frame it for whatever ability. If you've got lower ability students, you spend a lot more time with it. So the high-end students, that's when you start bringing in all the different, if you buy 2 Xboxes, if you buy 7 controllers. And then you get into a discussion, why is this important? Why is this important to anybody? And then we start drawing business, straight away like business. People buying goods, supplying goods. And then you have a nice 5-minute discussion, talk about potential other formulas, and they love it, they feel happy. Now they know, well, I'd like to think that they know what a formula is all about, why these equations are actually meaningful to them. Not just sitting there doing 20 equations, 3x minus 5 equals 7, where they just do them and do them and do them by rote. Now they've bought into it, and then you can sort of develop further. Now, another favourite of mine is, again, trying to get them to buy straight into stuff. I gave them an example. I did a big road trip down to Salalah during Eid, and it's a big distance. So I give them that information there and say, okay guys, work out how much is the cheapest possible for me to drive all the way to Salalah based on those petrol prices, based on the fact that my Jeep will only take 58 litres of petrol at Enoch, and that will only give me a distance of 340 kilometres. Off you go, work out the cost. So that's what they do. They sit there and you give them several minutes. They're working out the cost. Because there's no algebra yet, really. They work out the cost, and we're coming out at a price of, I think that was 302 dirhams 21. 302.21 dirhams. That's what they come up with. So that's what it's going to cost me to drive from Dubai all the way to Salalah. Okay, using obviously 1.72 dirhams per litre from Dubai to the Maziad border, and then petrol significantly cheaper. Brilliant. Okay, so now we thought, how did you get that 302 dirhams? Oh, well, we did this. Okay, if that's what you've done, use those calculations to come up with a formula for me, so I know if I'm driving down to Muscat next week, I'm going to go to the Hatta border, which is 140 kilometres away, and then it's 348 kilometres from the Hatta border to Muscat. Work out a formula to me so I can calculate any distance where I want to go in both the UAE and Oman. So again, it requires a bit of discussion. You let them sort of run at it, and they have a go at it, and they try to work it out. And eventually, again, they love C for costs. They're coming out at C, and it was like, they came, okay, it's 1.72 times, they brought in X, is it 1.72, yeah? And then they divide it, I think they have, what was it, it was 5 point something, and it's, what's this 5.8 that they came up with? Oh, so it's the fuel efficiency of your car. You do 340 kilometres with 58 litres of petrol, so you do 5.8 kilometres for every litre of petrol.
Independent research that could go on here. I've had kids that have gone away and come back the next day and said, oh, you know what, sir, I've helped you out, I've done all the work for you. Doing a Tissot are offering these, and if you buy the iPhone from Axiom, they're offering this deal at the moment, and someone else, and they're coming in with like pages and pages of graphs and working out. And you know, we're able to look at which is going to be best for me. And some of the students actually go and have actually changed their own phone networks based on that. So again, there's other options. With all of these real life ideas for algebra, there is always more extension and more independent research that is available, and I would encourage you to try and just let the students go with it, because half the time they come up with stuff that's so much better than me, and then next year I go, you know what, I'm actually going to use that, and it actually gives you teaching ideas as well. There are the results, so again, bring it back to them. Highlighted some of the bits there. The yellow one is obviously saying that option C is the best one. This is the amount of minutes, so up to 60 minutes. So long as I'm talking less than 60 minutes, then option C is the better. The red ones are the highlighted bits where they were the original questions for 1 hour, for 2 hours, and so on. So in terms of which one's cheaper, depending on your talk time, you know that if you talk less than 60 minutes or less, sorry, you're better off on option C. If you're talking more than 60 minutes but down to 190 or 200, then you might as well be on option B. And then over 200 minutes, you want to get to the flat rate because you're really going to be racking it up. And again, the kids have found this out for themselves. At the end of the lesson, you then tell them, actually, are you aware of, well, you let them decide what were the learning objectives of this, because they've forgotten the fact that they're in a maths lesson at this point. They think they're just throwing some ideas around. The fact that they've done some sequencing, the fact that they've done some graph work, the fact that they've probably talked about gradients, the fact that they've talked about y-intercepts, all of these objectives have come out in one lesson, but I haven't told them that because I know that if you say this is an algebra lesson at the start, they're going to be turned off straight away. All they've been doing is working out which mobile phone should Mr. Thurston get, all right? And he's pretty cool because he talks about mobile phones, he doesn't talk about algebra because algebra's boring. The next one is about the rich aunt, and again, it's about letting the kids sort of buy into you as a person as well, as a human being, rather than, you know, I'm the teacher, you're the student. They like to find out about you. So again, you can make up all elaborate stories. So I have this wealthy aunt, which I didn't realise was in my family, and she's a millionaire. What's the odds of that? It's absolutely fantastic. They're like, really? You're like, yeah. They're like, what's her name? You go, so you have to like plan a little bit ahead first of all. But basically, if we go on to the next one, please. Aunt Millie, that's her name, there you go. She's actually a millionaire, and she said that she's going to leave me some inheritance, but because maths is in the family, she's not going to make it easy for me and my brothers. So she's given us various options, and we're going to have to decide which one we want, okay? So that's the context of it. Again, the kids are on board. They're interested. They want to know, and you're telling them that you've got to get your maths off me now because in 2 years' time I might be retired off the back of all this money. Okay. So there are my 4 options. She's going to give me 2,000 dirhams in the first year, and then she's going to give me 100 dirhams less each following year. Okay. So 2,000. Simple questions to start off with. How much do I get in the second year then of this? You know, for some people they go, oh, 100 dirhams. Because it says 100 dirhams up there, but actually it's 100 dirhams less, so they're starting to get into the wording, okay? Again, you're then going into the sequencing, and often they'll say in year 1 you get this amount, year 2 you get this amount, year 3, again you get some bright spark that spots that they're all going in the same pattern, and says, oh actually I don't have to calculate anymore, I can just keep subtracting 100 from it. Option 2, she's going to start off with a low amount, but she's going to increase it every single year. Option 3, she's giving me minimal, and everyone goes, who would go with option 3? Hey, you get 1 dirham. That's rubbish. The other ones, you're getting a lot more for it. Twice as much every single year. Okay, now you know obviously know where that's going. They don't. They've ruled out option 3 immediately because 1 dirham's nothing. Doesn't even buy you anything in the shops. Option 4, she's going to give you 1,000 dirhams per year. So again, obviously we know where this is going. It's going towards sequencing. It's going towards graphing. As far as they're concerned, they're just interested who's going to make the most money. Okay. So we go on from there. A couple of questions to get them thinking about. Well, obviously, you know, we haven't even discussed how old my Aunt Millie is. So if she's giving me a certain amount of money each year, it actually depends on how long she's going to live for. Okay. So we need to then look at these values. So we're starting to think, what if she lives for 5 years? What if she lives for 20 years? Again, going back to what was Rob saying, what if she lives for N or X years? So you can bring in as much as you like and take it as far as you want. Commenting on their findings, again, stressing to them that you've got to be able to talk about this algebra. It's not just about getting a value, it's about what does it mean in the context of it, okay? Commenting on how some of them you're getting less each year, some of them you're getting more each year, some of them are going up really quickly each year, some of them are only going up a small amount each year. All of these comments, they're starting to get an understanding of what they're actually doing, and they're understanding the algebra behind it. So please promote discussion. Other things to consider. Okay, are there any problems with them? And they'll go, no, that's fine, no worries. Well, she's only a millionaire, so she's got £1 million. What happens if she lives for 50 years? Can she actually afford to back up these claims that she's made? You know, sometimes they come out with these sort of ideas, and maybe it's a case of how long can she actually go with some of these. Again, when is option 1 going to be better? When is option 3 going to be better? Again, linking it back to the inequalities. So 2 very, very similar tasks here. For extension, can you draw the graphs? Now these ones, some of them aren't going to be quite as straightforward as the straight line graphs. We're going to be starting to talk about curves, okay, and you can actually, if you have graphing packages in computers, you can actually get them to start modelling this. We have Autograph, which is a package which you have to buy into, but I know that you can get, is it GeoGebra, which you can download free from the internet. You can even use Excel for some of these things as well. So worst comes to the worst, good old-fashioned pencil and paper once they've calculated a few values. Again, extensions, can you devise a scheme so that I'm going to get £1 million in 20 years? Okay, because that's my aim. I want to retire, I want the yacht, I've planned it all out, but I need this million dirhams to make it happen. So they're going to give me these ideas to basically rob my poor old Aunt Millie. Okay, next one. So there are the graphs, and we look at this and go, well, all right, so now they've calculated it. Comment on this graph, all 4. Doesn't look very good, does it? Looks pretty rubbish. Why have I got a graph like this then? I've looked at it, so let's assume that Aunt Millie lives for 20 years. And again, it's a discussion point. Because I go, yeah, this is it, I've done it. And then they'll go, I can't really make out, I don't know. And you think, yeah, actually, that is pretty rubbish. Why? And you let them answer it. Well, and then you go into the discussion of what's actually going on for this one. Okay, well that actually is obviously looking at the growth by multiplier. All of these are the straight lines, so it's very, very difficult to see what each graph is showing. Then they start to think about which ones are important. Obviously the options 1, 2 and 4, they've realised that those along the bottom, and actually all along they should have been choosing option 3, because that was the one, although it starts off very low, because it's the multiplying one, the rest of them are adding and subtracting, it's the one that over time is actually going to take off and start to skyrocket. And you bring in the fact that, okay, how long can Aunt Millie actually back up this claim that she's going to keep doubling it every single year? How long will her £1 million actually, or dirhams actually last? Okay? So looking at cross-curricular links, quite often within JES what we try to do as a maths department is bring together other departments and say, can we try and work collaboratively? Okay, so for economics here, you can bring in a lot of savings and things like that. With PSHE, you can do that. You can perhaps bring in the English department to say, I want you to write a report on your findings, and you can speak to the English department about structuring it. So we're actually working together with various different departments. Sometimes we collapse a year group's timetable for a day, and we bring together 2 or 3 departments to work on this one activity. And the kids love it. We can bring in the primary schools to come in to actually see, and then the secondary school are presenting to the primary school, so you're getting in all the other life skills about presentations. So they do get into it a lot. Is that? And I think there are the final results and things like that. So again, going back to the original questions, you can use this. If she dies after 5 years, which was the best option, where we're actually looking at option 3, which they've all dismissed. By this point, they're going, oh, I told you so, I told you option 3 was rubbish. Look, you only get 31 dirhams. Ha, you lose out. You should have gone for option 1. Look, you'd have had 9,000 dirhams. I'm like, oh, okay, fine, you were right, I was wrong. Fair enough. And then when we go on, I go, yeah, but actually she lived for 20 years. So you only end up with 21,000, but I've got, what's that? Like over 1 million dirhams there in 20 years. So who's the last laugh on? They were sitting there with their 21,000 dirhams, I've got my 1 million dirhams. Now all of a sudden I've got pictures of my yacht which I've been planning to buy and things like this, and I'm retired and everything. Again, the context of it though, it's starting from something that they know about. It's grabbing them early on, you start the conversations, nothing to do with algebra, and then slowly feed these things in. It works at year 7, year 8 level because you keep the algebra simple. Maybe straight line graphs, okay? Maybe simple sequencing. You can take it as far as you want by changing those options, getting in all sorts of exponential graphs. You can even take it to IB. Just this morning, I was having a great conversation with the year 13s. I was introducing trigonometric functions to them. And they were like, oh, I hate trigonometry and I hate algebra, so this has got to be the worst thing in the world ever. And we were just looking at the sine graph, and all of a sudden I was like, you know what, has anyone ever lived by the seaside, got a boat or whatever, and usually there's one person who has done that, and you talk about the little books you get for high tides and low tides, and why are they important, so you can take your boat out and in at the right times and things like this. And I was like, but I never quite understand why that they can tell me in the next year, you know, how do they know on the 17th of July that there's going to be high tide at 11:21 in the morning, okay? And then you start to bring in from that sort of simple conversation, a couple of minutes, they're like, yeah, how is that? And you start to bring in the high tide, the low tide, and before they knew it, they were actually realising that the sine curve, and then you let them tell you that the high tide and low tide is actually following the sine curve, and then they think, oh, this is brilliant, they've taught you something. And again, you then start to go on to amplitude, you go on to the periods, you go on to the principal axis, and that's taken pretty much the same sort of graph work from year 13 all the way down to year 7. You just change it and adapt it for what you want. Thank you very much, hope that's been useful, guys. Yeah, sure, I'll be your strong figure tonight.
I'm Laura, and I'm just going to very briefly talk about, Ian's stolen half of my pitch, I think, about modelling real life situations. And initially, what I do when I'm talking about graphs, I'm going to go into graph transformations, I just bring a ball into the classroom and, you know, get them passing it around, and they're thinking it's great, they're not even doing maths, it's fun, they're throwing a ball, and then it's about, right, okay, so I've got this picture, is this ball actually going to get into the net? And they're all like, I don't know. And then what we do, as Ian has said as well, we've got autograph package, and what we can do is, without even an equation, just a normal quadratic equation, they can just, before I've even spoke about quadratic graphs, if you get this on the origin and then they just play about with the constant controller, and then they actually get a model for that graph, and it's, yes, it's going to go in, no, it's not going to go in, and then they can actually see just from a picture of someone throwing a basketball what it is. Then I just get them to, where do you see these shapes in real life? And then so go onto Google, get a picture, import it onto Autograph, and then they've got to come up with various equations. So if it's rainbows, fountains, the Sydney Harbour Bridge is a common one. Living in Dubai, what's a good one as well, like the sand dunes, and then that's on to not even quadratic, where you've got root x graphs, and they love it. They're like, wow, we've got it, mine's is more accurate, and it just grabs their attention. And then you can then talk about how many points do you need on a curve, and then it's like these three, can you come up with equations? Another good one is Angry Birds, like the game, and then you can pause it halfway, is it actually going to get, what's the equation going to be? And even like bouncing a ball, talking about graph transformations, can you get the two, how has it moved on? So that's just, they're doing all this and they're seeing what the constants do before they even realise that they're actually doing really any maths about it. We go on. As Ian has said, we're trying to do a lot of cross-curricular events, and how we're trying to incorporate algebra and graphing, because that is one thing that students struggle with, how they see an equation and then you've got a graph and they sometimes think they don't understand how to get it, they find it quite difficult. So Ian is modelling there a lovely catapult that we have done on last year. We have year 9 of timetable, and we have history where they do heraldry, they do a shield, so they've got the kids work in groups. The DT, they actually make their own catapult, and how we bring the maths and the algebra in is they have got to model the projection basically of their tennis ball or whatever it is they're projecting. The internet is such an amazing resource, and we've incorporated it where they do an online simulation, and then they're measuring all how they build their catapult with arm length. They've got to think about angles, and then we also, to bring in the modelling, we have a competition to see who can come up with the equation of, is it going to land on an X, the spot. So it's a really good day, and it does bring about the modelling. Because when you get to IB and it is about the trig curves, and you just think, how can I get a graph that models it? We've also had our IB students in the past model the Burj Al Arab. So it is just all about getting them to think, where do we see maths every day in our lives? And then this picture, you're allowed to have fun in maths, and they can have a great day, but they actually learn so much about it as well. And so yeah, that's mine. Okay,
Okay guys, I think